Hello, class. This is Mr. Hart, and in this podcast, I want to finish up the Earth's atmosphere chapter. And the last part of the chapter deals with air movement. Okay, and for most people, when I say air movement, they think of wind right away. Okay, and that's obviously one of the big ones, but we're going to be more specific than just wind, and we're going to look into different types of wind and some of the global winds that are constantly occurring around the Earth. Okay, and so we want to be very specific, not just thinking about air moves, right? We want to get into some details on this. Okay, but let's think about the basic idea of wind and air movement. Okay, so a lot of it has to do with air pressure and temperature. Okay, so you probably learned in a previous science class that hot air rises and cool air sinks, right? It's a pretty simple idea, right? Heat's going to go up, cold's going to go down. And you probably also learned that high pressures flow to low pressures. And I think I've described that a couple of times in class before. The idea that high pressure is going to flow to low pressures. Okay, so when we put both together, we get this convection cell. This idea of this, cycling air, right? Moving up, then down as it cools, then moving over from the high to the low, then moving back up, and then cooling back down. Okay, so when we feel wind, it's either from a hot to a cold area or a high to a low pressure. Okay, usually in this kind of convection cell. Okay, so that's the general idea. So let's look at the different types of wind. And so for all these different types, it's going to be some type of hot air, or sorry, some type of high pressure moving to low pressure, or hot air moving to, or cold air moving to hot air. Okay, it's always going to be the same idea. It's always this this convection cell process. Okay, so let's start with the first type. Okay, so the first type of wind is what we call land and sea breezes. Okay, so if you've ever been on the beach, you've probably felt a very windy day, either in the morning or in the evening. Okay, and this is because of these breezes. So let's think about the morning first. So in the morning, okay, let's say this is the sun, okay, up here. And so the sun is shooting down rays, right? It's going to heat up the earth and the sea. So think about which one would heat up first, the land or the sea. Well, if you think about it, the sea has a very high volume, very water has a very high specific heat, so it takes a long time to heat up. So this land is actually going to heat up quicker than the water is. So the water is going to be cold, the land is going to be hot. Okay, so that warm air is going to rise. Okay, and that cold air is going to go in to fill its place, right? And so you can see, I'll even just erase these arrows. You can see from what's drawn here that this cold air is going to flow over here. It's going to heat up from the earth. It's going to rise and it's going to cool back down as it goes over the sea. And so we get this convection cell. Okay, again. So if you're standing on the beach right here, okay, here's you. You're going to feel that wind flowing from the sea or the ocean towards you, okay? Coming from the ocean towards the land, okay? So now let's look over here. So by this time, let's say this is the evening now. So this is the evening now, and if you think about which one's going to cool first, the land or the sea, now the opposite's going to be true. So, or I should say, the land is going to cool first. So now the roles are going to be reversed. So now the land is going to be cold, and the ocean's going to be hot, or relatively hot compared to the land. Okay, because the land can cool a lot quicker than the ocean can. And so now we get the reverse happening. You have the cold air over here and the hot air over here. The hot air is going to rise, okay, and then the cold air is going to fill its place. And again, as it goes over the land, it's going to cool down, and we're going to get this convection cell again, but in the opposite direction. So if you are standing on the beach now, okay, the wind's blowing this way towards the ocean, okay, so it'd be towards the back of your head, you can think of it, okay. So the winds go in opposite directions in the morning compared to the evening. Okay, so we call this a land breeze, or a breeze going towards the land. And we call this a sea breeze, a breeze going away from the land into the sea. Okay, so example A is a land breeze. Example B is a sea breeze. Okay. All right, let's move on to the next one. So the next one is just a more intense version of this one. It's just called a monsoon wind. You probably heard of a monsoon, but you've probably never thought of it as a wind before. But it's just a larger scale version of a land and sea breeze. Okay, they blow from the sea onto the land in the summer and from the land onto the sea in the winter. And so these just high intensity winds. Okay, they're just the same idea, but it's just a very large difference in the land and the sea. Okay. Then there's the mountain and valley breezes. Again, the same idea, hot versus cold. So if you think about in the morning, okay, in the valley or the canyon, there's a lot less light reaching it because of shadows from the mountains, okay, and things like that. So you usually have colder air here and hotter air up here. So that hotter air is going to rise and the cold air is going to fill its place. So in the mornings, you have mountain breezes or wind going towards the mountains. Okay, and then at night you have the opposite effect. So the mountains are going to cool first before the valley. Okay, and so now that cold air is going to go in to fill that place, and so now you have a valley breeze or wind going towards the valley. Okay, so if you've ever lived near a canyon, you'll know that you have very intense winds during mornings and the evenings. This is often why they build um, windmills near canyons, or solar or power generating windmills near canyons because they know they can get consistent airflow in those areas. Okay. All right. Then the next type of wind, we're getting a little bit more specific. Okay. The land and sea and mountain and valley breezes are very general idea. These ones are a little bit more specific that we're getting into. Okay. So a katabatic wind, it moves up and down slopes. Okay, but they're stronger than mountain and valley breezes, and they usually form over plateaus. Okay, so here's a plateau. Okay, very cool plateau. Let's say it's snow covered. Okay, you have cold air or a high pressure air compared to the valley. Okay, which is a low pressure air, and so you'll get that movement from the high pressure to the low pressure. Okay, or down this slope. Okay, so areas that have plateaus, I'm thinking more like Montana and North Dakota type areas would probably get more of the katabatic winds. Okay, and so again, it's just these slopes from these plateaus. Okay, is when we call it a katabatic wind. Okay, next one is called a Chinook wind. Okay, or a phone wind, and these are very interesting types of winds. They happen when air is forced over a mountain range, okay, usually because it's raining on the other side. Okay, so if you think about it, you have over here on this mountain, part of the mountain, you have rain or kind of a cooler air over here, or a high pressure air. And so if it's on this side of the mountain, it's going to be forced over this mountainside and then come down the mountainside to the warmer valleys below on this side. And so it's kind of like a mountain or valley breeze, but it's usually caused by a rain, some type of rain on this side, which causes the air to cool on this side and be warm on this side. And so it goes over that mountain slope and goes down. Okay? Does that make sense? Hopefully that does. Again, let me know if you have any questions on that. Okay, and then the last one is a very specific wind. It's called the Santa Ana winds, and they are created in the late fall and winter. Okay, specifically near the Sierra Nevada or Sierra Nevadas, and it's when the Great Basin to the east of those cool, and they create a high pressure zone. So if you see this picture right here, this is actually an aerial view. Okay, so here are the Sierra Nevadas. Okay, this Great Basin area to the right of it cools down. Okay, causing a low or a high pressure, and it blows to the west over the Sierra Nevadas. Okay, And so these are called Santa Ana winds because this is in the Santa Ana part of California. Okay? All right. So hopefully that makes sense. Hopefully you understand all the different types of winds. Okay? But again, these are all for low atmosphere. Okay? These are very local features. And so the last type of winds we want to cover are what we call global winds, okay, or atmospheric circulations. Okay? So this picture is of the Earth. Okay? It's um, a upper atmosphere picture of which way the winds go. And so again, if you think about it, in the upper atmosphere, there's not a lot of things that can vary. Okay, there's not a lot of mountain ranges that are interfering or things like that. And so the wind patterns are going to be very consistent. Okay, so they're going to blow to the west near the equator and to the east near the poles. Okay, and we'll talk about more why that is in a second. But I just want you to kind of get this general idea. Is near the equator we get west winds, and up here and down here we get kind of these eastern winds. Okay, we can also look at it from a circulation idea, right? So near the equator you get very hot air, right, from the direct sunlight. So that hot air rises, okay, and then it's going to cool down and cause these convection cells. Okay, so these are global cells, which you call Hadley cells and Faro cells and polar cells. Okay, and so these are consistent again, and they are again just caused by simple convection. Okay, so this is the general pattern for the entire Earth, right? For the upper atmosphere, you're not going to get a lot of variations because it's very consistent. There's not a lot of interference. Okay, so let's talk about why we don't just see one big cell. Because a lot of students think, well, it's hot here, right, near the equator, and it's cold here. So why isn't there just one really big cell that goes like this? Okay, hot air rising, cold air going down. Okay, and it turns out you would be right if the Earth wasn't spinning. Okay, so if the Earth wasn't spinning, you would just have hot air rising, cold air cooling down here, and this one big convection cell. But because the Earth's spinning, we get something what's called the Coriolis effect. Okay, and so it's a little bit hard to explain, but because we have this Coriolis effect, or in other words, things are spinning slower up here and a lot faster down here, we kind of get these break-off points, okay, which we call the Horst latitudes and the polar fronts. Okay, we get these different break-off lines where the air is kind of moving at different speeds because it's spinning at different rates. Okay, and so because of that, we don't get one nice pattern. We get these different winds. Okay, and so again, that's called the Coriolis effect, but it just means because the Earth's spinning, we don't get one nice smooth picture. Okay, but hopefully that makes sense. Again, just to kind of memorize the kind of the layout of this picture. Again, the west winds near the equator and the east winds near the poles. Okay. All right. And then the last thing I want to talk about is the jet streams and the prevailing winds. Okay. So if you've ever flown in an airplane, you know that there's something called a jet stream that goes east in the United States. It goes from the west to the east side. Okay. And it's an upper atmosphere wind that is very consistent. Okay. And airplanes use this wind to plan their flights because they know if they're flying against it, it's going to take longer, and if they're flying with it, it will go a lot faster. Okay, and so jet streams um, occur from again these convection cells, and we also have the prevailing winds, right, which we saw. Again, the west in the near the equator and the east in the near the poles. Okay, and so these prevailing winds and the jet streams are caused by these convection cells. And so you can think of these jet streams, they come from the meeting points of the convection cells because there's not a lot of resistance in that area, and air can move pretty fast through those meeting points. So here's a polar jet, here's the subtropical jet, which is probably what we call the jet stream. Okay, and so it's just a very complex situation because of this convection cells and the Coriolis effect. But hopefully that all kind of makes sense and kind of wrap your head around it. Okay. But again, just remember this picture, some of the main ideas, and remember also all the local winds we talked about and the different types. But let me know if you have any questions, and thank you for watching.